We have this really clean corporate image of where our tech comes from. We picture these sleek labs, brilliant minds in hoodies, that kind of thing. But what if I told you the real story is, well, a lot stranger? What if the DNA of the phone in your hand started not in Silicon Valley, but in the minds of some of the most eccentric people of the 20th century?
Yeah, you can forget those sanitized corporate histories. The DNA of the very device you're using right now is coded with some serious eccentricity. And these people aren't just footnotes in history books. They are, quite literally, the source code.
So that's the real question, isn't it? Who are these people? Well, let's pull back the curtain on three pioneers whose quirks weren't just side notes to their careers, they were absolutely essential to their genius. And we're going to start with the one and only amazing Grace Hopper. She was an absolute force of nature in the world of early computing. So, we have this legend of Grace Hopper as this brilliant visionary, and she was, but the reality? Oh, the reality was even more impressive. She was this tenacious, hands-on problem solver who would get right into the wiring and just flat out refuse to believe that computers had to be so incredibly hard to use. So picture this. It's the late 1940s. A computer the size of a room just grinds to a halt. The whole team investigates, and what do they find? A literal moth stuck in a relay switch. Grace Hopper, ever the pragmatist, carefully pulls it out and tapes it right into the logbook. And just like that, the term debugging your computer was born from a very, very real bug. But her biggest legacy wasn't an insect. It was this powerful, truly revolutionary idea. She fought, and I mean fought, for programming languages that were based on English words. She wanted to make computers accessible to everyone, not just a handful of elite mathematicians.
Okay, next up, let's talk about the maverick mind behind the very blueprint of pretty much every modern computer, John von Neumann.
The legend of von Neumann is just this towering intellect, a true polymath who changed physics, math, and economics. The reality, though, was a guy defined by some intense and, yes, some pretty peculiar personal habits that actually fueled his relentless focus. Now, this idea is absolutely fundamental. See, before von Neumann, computers were basically just giant single-purpose calculators. His architecture, this simple but totally game-changing idea of storing both program instructions and data in the same memory, that's what turned them into the flexible, all-purpose machines we have today. It is the design at the very heart of the device you're using right now. This incredible focus he had, it was his superpower. He would just work to the exclusion of everything else. And that allowed him to solve problems other people couldn't even begin to wrap their heads around. For him, personality and process were completely intertwined. You couldn't have one without the other. And that brings us to our final figure, who might be the most enigmatic of them all, Claude Shannon, the man who somehow turned pure information into math. I just love this slide, because on one hand, you have this profound genius who literally created the entire field of information theory, and on the other hand, you have a guy who built flame-throwing trumpets and was famous for riding his unicycle down the halls of Bell Labs while juggling. But don't let the juggling fool you for a second. Shannon's genius was in realizing that all information, I'm talking words, sounds, pictures, everything could be boiled down to a single unit, a bit, a simple yes or no. By turning information into math, his theory gave us the tools to send and store it perfectly. It's the reason your messages arrive uncorrupted, and it's how you're able to stream this right now. He actually saw a deep connection between all that playful tinkering and his serious work. For Shannon, the freedom to play, to build these bizarre contraptions and juggle, that was essential to his discovery process. It wasn't a distraction from the work, it was the work. So, okay, these were clearly not your average engineers. But how does all their strange genius actually connect to you right here, right now? Let's connect the dots. All right, let's start with Grace Hopper. Back then, the idea that a computer should be user-friendly was honestly a radical idea. She faced this huge uphill battle against an establishment that really believed computing was only for an elite few. And now? Well, every single intuitive app you tap on, every simple interface you use, that is a direct result of the world she imagined and fought so hard to build. Then you've got John von Neumann, literally just sketching out a pure concept on paper, this fundamental architecture for a machine that could actually be programmed to do anything.
And today, that concept is the humming, beating heart inside the very device you're holding in your hands. It's not just history, it's the hardware making all of this possible. And finally, Claude Shannon. He took something as messy and unpredictable as communication and somehow turned it into elegant, abstract mathematics.
And that math? It's now the invisible force, kind of the ghost in the machine, making sure this video reaches you without a single pixel out of place. You see, their legacies aren't separate. They're all layered on top of each other, working together at this very moment to make your digital life possible. So when you look at all three of them, you start to see the pattern. Their unconventional minds, their quirks, their so-called madness, that wasn't a bug in their genius. It was the genius. It was their source code.
And it really leaves you with a final question to chew on. When we're looking for the next great breakthrough, should we be looking for perfect resumes? Or should we be looking for the brilliant, unicycling jugglers of the world?